I fell down a quantum computing rabbit hole last week that kept me up for 3 nights straight. Amazon just dropped something that changes the entire quantum race, and almost nobody's talking about it. While everyone was obsessing over Google's Willow chip, Amazon quietly announced Ocelot, a quantum processor using something called Cat Cubits that solves the biggest problem in quantum computing. And when I dug into the details, I realized this could accelerate practical quantum applications by years. By the end of this video, you'll understand what makes Amazon's approach different, why it matters, and what this means for the future of computing. Let's dive in. Amazon announced Ocelot in February 2025, a quantum chip built entirely around Cat Qubit technology. Now, if you're wondering what a Cat Qubit is, hang tight. I'll explain that in a minute. Here's what you need to know first. Ocelot contains 5 cat data qubits, plus 4 additional error correction qubits. That's 14 total quantum components working together on dual-stacked silicon chips. The breakthrough isn't about having the most qubits. Google's Willow has 105. Amazon's playing a completely different game. They're focused on solving quantum computing's biggest enemy, errors. Traditional quantum computers need about 90 physical qubits to create just one reliable logical qubit. Amazon's Cat Qubit approach? Only 9 physical qubits per logical qubit. That's a 90% reduction in the resources needed. And that changes everything about how we build practical quantum computers. Okay, here's where it gets fascinating. Cat qubits are named after Schrödinger's famous thought experiment, the cat that's both alive and dead until you observe it. In regular qubits, information exists in what's called superposition, like a coin spinning in the air that's both heads and tails simultaneously. But here's the problem. These quantum states are incredibly fragile. Environmental noise, temperature fluctuations, even cosmic rays can cause errors. There are 2 main types of quantum errors: bit flips and phase flips. Think of bit flips like your data randomly changing from 0 to 1. Phase flips are more subtle. They mess up the quantum relationship between different states. Here's what makes Cat Qubits special. They're naturally protected against bit flip errors. Amazon's Ocelot can maintain stable quantum states against bit flips for over 1 second. That might not sound impressive, but in quantum computing, that's massive. Traditional qubits lose their quantum properties in microseconds, millionths of a second. Cat qubits extend that to full seconds. That's like comparing a camera flash to a steady lamp. You can actually do complex calculations before the quantum state collapses. The technology uses superconducting tantalum circuits, materials that conduct electricity with 0 resistance when cooled to near absolute zero. Amazon fabricates these on dual-stacked silicon chips with atomic-level precision. Every component has to be positioned perfectly, or the quantum effects disappear. Let me put this 90% reduction into perspective, because this is the real game changer. Traditional quantum error correction is brutally inefficient. You need massive redundancy, 90 or more physical qubits working together to create one reliable logical qubit that you can actually use for calculations. It's like needing 90 backup singers just to ensure one note comes out correctly. Amazon's Cat Qubit approach flips this equation. Because cat qubits are naturally resistant to bit flip errors, you only need to protect against phase flips. That drops the requirement from 90+ physical qubits down to just 9 per logical qubit. Think about what this means for scaling. If you want to build a quantum computer with 1,000 reliable logical qubits, traditional approach, you need 90,000+ physical qubits. Cat Qubit approach, you need 9,000 physical qubits. That's the difference between a quantum computer that fills a warehouse versus one that fits in a large room. It's the difference between spending hundreds of millions on cooling systems versus tens of millions. This research was published in Nature Journal, one of the most prestigious scientific publications. Amazon didn't just make claims, they provided peer-reviewed evidence that this approach works. So when does this actually matter for real-world problems? Let's talk practical applications. Drug discovery is the most immediate opportunity. Simulating how molecules interact requires calculating quantum mechanical effects. Classical computers can't do this efficiently. They have to approximate. Quantum computers can simulate these interactions directly. Current drug development takes 10 to 15 years and costs billions. If quantum computers can accurately simulate molecular interactions, we could test thousands of drug candidates virtually before ever entering a lab. Amazon's error reduction breakthrough makes these simulations more reliable and accessible. Logistics optimization is another huge area, and this one's personal for Amazon. They run one of the world's largest delivery networks. Optimizing routes for millions of packages across thousands of vehicles is exactly the kind of problem where quantum advantage appears. Finding the absolute best solution requires testing astronomical numbers of combinations. Quantum computers can explore multiple solutions simultaneously through superposition. More reliable qubits mean more accurate optimization results. Financial modeling, climate simulation, materials science. These all involve complex systems with countless variables. The 90% reduction in physical qubit requirements means companies can access quantum computing power sooner and cheaper than previously expected. Amazon already offers quantum computing through AWS Braket, their cloud platform where you can rent quantum processing time. As Cat Qubit technology matures, these services become more powerful and cost-effective. Now let's talk about the elephant in the room, Google Willow. Google announced Willow in December 2024 with 105 qubits. They demonstrated something called below-threshold error correction, meaning adding more qubits actually reduced errors instead of increasing them. That's a major achievement. But here's what's interesting. Amazon and Google are pursuing fundamentally different strategies. Google's approach: scale up qubit count while improving error rates. They're building bigger quantum processors and refining traditional error correction methods. Willow represents incremental but important progress on this path. Amazon's approach: change the fundamental qubit architecture to be naturally error-resistant. Instead of fighting errors with massive redundancy, build qubits that don't make as many errors in the first place. Neither approach is better. They're complementary. Google's strategy might reach certain computational milestones faster. Amazon's strategy might be more practical for commercial applications. Think of it like two routes up a mountain. Google's taking the established trail with better equipment. Amazon's cutting a new path that might be shorter, but requires proving the route works. The quantum computing race isn't winner-take-all. Different approaches will likely excel at different types of problems. Competition drives innovation, and we're seeing both companies push boundaries in different directions. Your delivery routes might be more efficient. First, practical quantum applications are getting closer. The timeline for useful quantum computers keeps shrinking. 5 years ago, experts predicted 20-plus years until practical applications. Now we're talking 5 to 10 years for specific use cases. You won't buy a quantum laptop. Quantum computing will work like cloud services. You'll access it through applications without knowing it's there. Your drug prescriptions might be developed faster. Your investment portfolio might be optimized better. Second, this validates that multiple paths to quantum computing exist. We're not locked into one approach. Cat Cubits, topological qubits, trapped ions, photonic systems. Different technologies will likely serve different purposes. Third, the tech industry is in a genuine quantum race. Amazon, Google, IBM, Microsoft, and others are investing billions. When tech giants compete like this, progress accelerates. Breakthroughs in one lab push others to innovate faster. For creators and entrepreneurs, quantum computing represents a massive knowledge gap. Most people don't understand it. Those who learn quantum concepts now, even at a basic level, position themselves for opportunities as this technology matures. The companies that figure out how to apply quantum computing to real business problems first will gain enormous advantages. We're watching the early stages of a technological revolution. Amazon's Ocelot proves that quantum computing is moving from theory to practice faster than most people realize. Cat Qubit technology solves the error problem in a fundamentally different way. And that 90% reduction in physical qubit requirements is a genuine breakthrough. We're still years away from quantum computers in every data center. But the progress is real, the competition is fierce, and the implications are massive. Drop a comment. What industry do you think quantum computing will transform first? Healthcare? Finance? Logistics? I'm curious what you think. And if you want to stay ahead of AI and quantum developments, hit subscribe. This technology is moving fast, and I'll keep breaking it down in plain English. Thanks for watching. I'll see you in the next one.